In today's fast-paced digital landscape, maintaining application performance and scalability is more important than ever. Without a robust observability strategy that integrates monitoring, telemetry-driven insights, and autoscaling, your app risks inefficiencies and performance bottlenecks. My name is Sean Lee. I'm from the Java team at Microsoft, and in today's session, let's delve into how you can leverage tools offered by Azure, including Managed Grafana dashboard and Azure Monitor, to gain deep insights into application health, performance, and resource utilization. We'll then explore strategies to dynamically scale application based on real-time telemetry and workload demands using KEDA or Kubernetes Event-driven Autoscaling to ensure optimal performance and application resilience. We'll start by introducing an app that simulates memory allocation and GC behavior. We will generate traffic to our app to induce garbage collection. Then we'll set up some autoscaling rules to horizontally scale out the app to reduce GC count per app instance. And finally, we will monitor the entire scaling process and GC behavior in Azure Monitor and Managed Grafana dashboard. The code I've prepared to demonstrate these concepts is very simple. The part that is relevant to the demo is in this REST controller, where we create a list of new objects based on the number from the input. At the end of the for loop, we will remove all references to the created objects and making them eligible for GC. Now, you may have noticed the code does not directly trigger GC, and it's entirely up to the JVM to decide when to perform garbage collection. This is why we want to run this for loop for a large number of times to induce the GC behavior. Let us deploy this app to Azure Container Apps. I've prepared a script for the deployment, starting by setting some environment variables for my resources. Execute the command to create my resource group. And deploy apps to Azure Container Apps using the all-in-one AZ container up command. The deployment will take several minutes to complete, and in the interest of time, I've already prepared a working instance for the demo, so let's go ahead and use that. The first thing you want to do is to set the development stack to Java and enable both core JVM metrics and Java Diagnostics Foundation. With these options enabled, Azure Container Apps starts to capture detailed telemetry about the state of the JVM, and we'll see that in today's demo. You also get access to manage Java components for app configuration, Spring Boot admin, gateway, etc., etc. You can even dynamically change log levels and capture dump files without having to restart your apps. We need Azure identities for Azure Monitor and Grafana to access your data telemetry. Now, this step is a bit involved and out of scope of today's session, but I'll make sure to leave a link in the end of the video to provide instructions to carry out those steps. With those configurations in place, let's set up some auto-scaling rules. I'll allow my app to dynamically scale between 1 to 10 replicas with a cooldown period of 300 seconds. What triggers the scaling is defined in the custom scaling rule. In KEDA, there are predefined rules and there are custom rules. I've created a custom rule here. There are a number of attributes in this table, and I'm going to go to the KEDA website to explain what these attributes mean. Most of these are self-explanatory. Tenant ID, resource group name. Metric name is the name of metric emitted by Azure Container Apps. The target value is the most important parameter in the list. This defines the target value of a specific metric. In the demo, I've set the target value to 30 and metric name to JVM GC count. This means KEDA will scale out my app whenever the GC count exceeds 30 in any of my replicas. One more time, Azure Container Apps will scale my apps within the range of 1 to 10 replicas to keep garbage collection of any of my app instances under 30 per 30 seconds, or on average 1 GC per second, which is much easier to say. Got it? Let's take this scaling rule for a test drive. I'll generate some traffic by hitting the HTTP endpoint exposed by the REST controller and create 1 million objects to trigger GC. And while that's running, we can head over to Azure Monitor and add a couple of metrics. The first one we'll add is replica count, using maximum for aggregation. And as you can see from the graph, number of replicas fluctuated between 1 and 10. Let's add a second graph. We'll pick a GC count for metric. GC count is under the JVM category. And we'll apply a split filter, and we'll split it by replica name. With this split, you will get a view of GC count for different replicas. From the existing dataset, you may have noticed that I already ran the generator 4 times, and each time produced a spike in the y-axis. I'll zoom in on the last occurrence, and here you can see my initial replica took a barrage of hits. Then Autoscaler kicked in and distributed traffic among new replicas. At the end of this time continuum, the generator stopped and GC count for all replicas dropped to 0. Grafana is an all-time favorite for Java developers to visualize application telemetry, and we have received a lot of customer asks to monitor Java apps on Grafana. Good news is Azure offers a managed Grafana service and seamless integration with Azure Container Apps. To create a Grafana dashboard, simply go to the Azure portal, click Create a Service. In the menu bar, search for Grafana. Select Azure Managed Grafana Service. Create, and follow the Azure portal UI to create your Azure Grafana service. Over here, I've already got an instance created. We can access the Grafana service from my endpoint. Click Continue. And this brings me to my Azure Managed Grafana dashboard. Let's add a new dashboard. Import dashboard. And upload a configuration file. I'm going to add a configuration file from a GitHub repository. This is a GitHub repository under Azure Samples, where we kept a customer configuration for Grafana for Java apps running on Azure Container Apps. There are other configuration samples you can find on the web, or you can modify this one to fit your needs. The configuration file in a JSON format defines instructions to visualize metrics, including where the data feed is coming from, various panels and roles to display app telemetry. Here's where we've defined to display the container CPU usage in a time series. We are also going to display JVM memory used, GC, dimension filters and operators. And after uploading that JSON file, I get a dashboard that looks like this. Now up on top, you see filters for data source, subscription, resource group, etc., etc. Now, you may be wondering, why is my resource group named Frank? Well, Frank is the engineer who helped me build this demo. So I want to give a big shout out to Frank for helping me with JDConf this year. And look, you can even filter by replica and revision name. How cool is that? Remember the JSON file where we define CPU and memory to be displayed in a time series? So this is where it's displayed. And then you also have a list of all your historical replicas in this list. You have different types of JVM memory displayed on this dashboard: direct memory, non-direct memory, used and limits, heap size, JVM memory by pool. Let me quickly scroll down and find the section where you have GC information. There it is. Expand on the chevron. So here you see container replica number equal to 1. So when you have one replica that is processing all that incoming traffic, and my GC count and GC duration are both very high. Let me refresh the screen and get an updated view of my metrics after the horizontal scaler kicked in. Number of replicas has now increased from 1 to 7. GC count and GC duration both sank to the floor after new replicas are spun up and distributed incoming memory allocation requests, which is exactly what we hope to see as it simulates a dynamic telemetry-driven scaling scenario. We've seen how you can use Azure Monitor, Grafana, and Kida to gain deep insights into your Java application's resource utilization and enable intelligent demand-driven scaling. By leveraging real-time telemetry and automation, you can optimize for performance, reduce costs, and ensure your application dynamically adapts to workload changes. Now, everything I just showed you, you can do it on your own by following documentation from the Java on Azure Container Apps website. Thank you for watching and have fun at JDConf.